that's great. And so yeah, I mean, if you want to say something textual, you can use the chat support, or if I'm asking some simple questions, I'll be asking to you with you like in which you can just react. So can I just get a thumbs up from you as an acknowledgement that yeah, we are going to do this? All right, I can see some emojis. All right. So today I'm going to talk about end-to-end encryption and how it works under the hood in Excalidraw. Before we actually dive into it, I'll just give a quick intro about myself. I think Shreya already did that, but since I have a slide for it, so I'll go about it. So yeah, I'm Akansha. I work at Excalidraw. I'm one of the core maintainers of the open source editor Excalidraw. And I also am one of the organizer of these FOSS meetups, which happen at Bangalore. You can connect with me on Twitter, GitHub, LinkedIn. And if you want to talk about open source, front end, anything, I'm all in for that. And if you want to check about my blogs or my previous session or podcast or any more info, you can check out my website, akansha.dev. So that was like a quick intro about me. These are like few picks about the last few meetups. And if you are in Bangalore, then we are having our next meetup on 25th March, that is coming Saturday. So do try to attend. I would love to meet you in person. So now let's start the interaction part. How many of you actually know about Excalidraw or have been using Excalidraw in your day-to-day life? You can maybe just give me an emoji so that I can understand that it's a +1 or not. All right. All right, I can see some of it. Maybe I don't think every one of you is in the gallery view. So I can see some of the +1, so that's good. So I have a quick demo about Excalidraw, which I'll just go through. And for the people who haven't checked it out, I would request them to check out, and I'm sure you will like it. So let's just do the demo. Just give me a second. Let's move this. So yeah, so you can just go to Excalidraw, just type in excalidraw.com, and the editor just booms up. There is no sign up or login process as such, so zero friction. You can just get the editor and get started with your drawing. So let's maybe draw a rectangle, and since it's Pesto text, maybe I'll write Pesto text here, and maybe just do some resizing. Maybe use some arrow. We also have images supports. Maybe I'll try adding some image. And 1 second, I think I could not, I just deleted it, what I had it. So yeah. And by the way, we have a very good collection of the libraries, so you should definitely check it out if you haven't yet. Kudos to all the contributors who have actually created this amazing libraries. Let me just pick one of it. Maybe I'll pick DataViz by DBS Sticky. And maybe I'll pick this one. So yeah. And yeah, you can just play around with it. We have collaboration, so you can collaborate with your team as well. You can even share your drawings with someone, and pretty much all the features which you would be looking for when it comes to a drawing app. So yeah, that was a quick demo about Excalidraw. Now let's go back to the slides. So how many of you have actually used Excalidraw maybe for collaboration or maybe by collaborating with your team or friends? How many of you have actually done that? Maybe you can just again use the emoji to just react. Okay. So basically, let's consider this example that, all of us are in the same team and we are building some cool startup and we are all in the same team and we are building some feature and I'm going to design the mock-up for that feature. So since it's a company feature, it's confidential, the data is confidential, of course, and I'm going to use Excalidraw to design that mock-up and I'm going to share that mock-up with you. So as an app, how Excalidraw can make sure that me as a user don't have to worry about the data privacy at all. So Excalidraw can actually take care about the data privacy. It will make sure that the privacy is maintained when we users are actually sharing our drawings. So how Excalidraw can actually help in that? So for that, we have end-to-end encryption. And by end-to-end encryption, what I mean is Whenever there is a data exchange between a sender and a receiver, nothing in between will have access to that data, which means that the data gets encrypted on the sender's end and gets decrypted only on the receiver's end. And for that matter, like not even the server in between will have the access to the data. And this will give you the maximum level of privacy, right? So before we actually dive into how end-to-end encryption works under the hood in Excalidraw, let's just have a quick overview how encryption works in our traditional client server architecture. So let's actually first understand that. So in a traditional client server architecture, whenever there is a data exchange between a client and a server, that channel, that network is actually encrypted with the help of HTTPS. So that's great. That's something that's something which is great because no one can actually tamper the data when doing the transmission. But if you notice, we are storing the raw content on the server. And what if someday the server gets compromised? Your data could get breached, right? Your data could get compromised too. And that is something which we really wanted to avoid in Excalidraw. So we came up with another model that, hey, instead of sending the raw content over the network, let's first encrypt the content on the sender's end and send that encrypted content over the network and store the same encrypted content in the server as well. This would mean that even if the server is compromised for some reason later, the content is still safe because it's encrypted. And this way, we don't really have to worry about data getting breached because the data is actually encrypted. But for this to work in reality, we need to consider two things. The first is the server should never have access to decrypting the content. The server should never have access to the key with which you can actually decrypt the content. That is the first thing. That way, only server will not be able to decrypt the content, and the content will be safe. And the second thing is, since in this entire process, the server is not really playing any role in encryption or decryption, which means it's the responsibility of the client to handle the encryption and decryption part completely, which means we need to come up with something so that the encryption and decryption can be done on the client directly. So these are two things we first need to investigate and solve. So let's take it one by one. The first thing is we need to hide the encryption key from the server. So how do we go about solving it? So for that, actually, it's like really interesting the way it was solved. So if you notice, whenever you have this URL, and if you have this hash, whatever is present after that hash is never ever sent to the server. And that is actually the default browser behavior which you get out of the box. So, I mean, we are not doing anything on top of it to achieve this. It's something we are getting out of the box. So in this case, if you see, key equal to XYZ is never ever sent to the server. And why not use this behavior of the browser to store the encryption key right after the hash? That way, it will never be sent to the server, and I can directly share this URL with you so that you can view the mockup, right? Because you will have the access to the key with which you can decrypt the data, and the server is not going to have access to it. So the first thing is solved. Now, the second thing is still remaining, that we need to handle the encryption and decryption completely on the client. But that was something we really didn't need to worry because we have the web crypto APIs for it. So basically, these web crypto APIs are the browser APIs, which helps you to do the encryption and decryption directly on the browser. And it has great support in the majority of the browsers, as you can see. So yeah, I can see some warning here. Okay, maybe someone just invert closed captioning. So yeah, so that it has great support in the majority of the browsers. So we decided to go ahead with the web crypto APIs. So before we actually go into how this API works and you go into the implementation, let's actually understand some basics which we need to know before we actually start using these APIs. So let's have a quick overview of the crypto APIs. So the API which we are going to use is crypto.settle. And if you are wondering why it is like named as settle, it's basically these APIs are very low level cryptographic APIs. And when you use these APIs, you will realize that these APIs have some very strict and strict rules and regulations which you need to follow if you want to use a particular algorithm to achieve the maximum security out of it. And it will give you some warnings as well, but it's something which you need to figure out. So that's why it's like named as subtle, because these are very low level cryptographic APIs. So it's available in HTTPS, which means you can only use it in secure mode. Uh, these APIs are very generic. By generic, I mean that you don't have specific APIs for specific algorithms. Rather, the APIs are very generic, which means that you have the API stays the same. What changes is the parameters. So algorithm will change, the parameters which are required by the algorithm, those will change, but the API signature will stay the same. So that way you don't have a learning curve when it comes to a different algorithm, because the APIs are like very generic. If you know about the algorithm very well, and if Crypto.Subtle supports it, you can just go ahead and use it. It deals with only binary data. So when you are actually using these APIs, you need to make sure that whatever input and output you will be getting is binary data. So that is the only way you can interact with this API. So that is something to keep in mind. So going forward in the rest of the talk, I'll be talking a lot about binary data as well. And most of the APIs actually return promises. So we will be using async await as well. So that was like a quick overview about Crypto.Subtle. Now, if you notice, we are going to talk a lot about binary data, because that is the way you deal with these Crypto.Subtle APIs. So how do you actually deal with the binary data when it comes to JavaScript? Well, if you know that JavaScript is not really a strictly typed language, because if you have, like most of you would know that, when you can actually store anything and everything when it comes to arrays. Like you can store numbers, strings, decimal, floating point, everything in a single array, right? But if you have used languages like Java or maybe C#, and those, they have different data types for different types of arrays. So integer will have an integer array. For string, you have a string array. So in JavaScript, we have something called typed arrays, which helps you to deal with binary data. Now, typed arrays is not really any category of any reserved keyword in JavaScript. It's basically a category of arrays which helps you to make sure that you can in these arrays you can actually store only numbers, and there is a list of arrays which comes under this category, which I'll be covering in next. But yeah, typed arrays is something which helps you to interact with binary data directly from the browser. So we are going to use typed arrays to deal with binary data. So these are the typed arrays which are supported, and we are not going to cover all of it. Don't worry about that. We are just going to cover UA8 array. And UA8 array is basically U is basically unsigned, int is for integer, 8 is the size of each index is going to be 8-bit. That is what UA8 array stands for. And most of the time, UA8 array will work out for you. It's like one of the most recommended typed array when you want to deal with like crypto APIs as well. So for our use case also, it was working out well. So we went ahead with this one. But if you want to check out the other types, you can actually visit the MDN docs, and you will find detailed description about all these different typed array views. So yeah, now we are going to use UA8 arrays. And how does it actually internally work? Like we just said that it's going to help us deal with the binary data. So how does it actually work? So let's consider this stream of bytes. Now what happens is, since the size of each index is going to be 8 bits long, this gets divided into 8-bit segments, and each 8-bit segment gets converted into its equivalent decimal. And this is actually what you see in the browser when you are viewing the UA8 array. So internally, of course, it's those stream of bytes which I just showed you, but when you are viewing it in the browser, this is what you see. So yeah, now, and since it's 8-bit, so the value range will be between 0 to 255. Now, we just covered how it is working internally. But how do you use it? Like, what is the syntax? So let's just have a quick look on the syntax as well. So you can cover, or you can actually initialize it with some arbitrary length. It will be filling it with all zeros. You can even initialize it with some arbitrary values. But since this stores only numbers, so how do you actually represent string to UINT array? So for that, we have another API, text encoder.encode, which basically converts the character of character of that string which you are passing to its equivalent decimal or the ASCII value. So that's what you get a UINT array when you actually run this text encoder.encode API over any string, and it works for the emojis as well. So pretty much everything as per the requirement of Excalidraw, it is covered with the help of UINT array. So I think, yeah, that's we have decided the type of array which we are going to use. So what is the next thing? But before that, actually, I have a small simple quiz for you. So what do you think will be the output of this expression? Don't run it in the browser. Actually, just make a guess. What could be the output of this? Maybe I'll try to see if someone is trying to answer here. Maybe you can just make a quick guess because I just mentioned that it's going to store positive numbers, but it's a negative number. So what do you think will be? Will it throw any error? Will it work? Will it, do some magic? What it will do? All right, I can see some responses here. So I'll actually tell you the answer. Let's break the suspense. It's actually going to be 251. So what happens is whenever the range goes beyond the limit, let's say it goes beyond 0 in this case, it will start adding the 256 unless you get it between that range, between 0 to 55. So in this case, 256 is being added to -5 and you get 251. And similarly, if you go beyond 255, 256 will be getting subtracted. So it's as simple as that. So yeah. So now I think we all understand that we are going to use UINT array and how it is working. I think this quiz also, I'm happy that you are all interacting as well. So yeah. So let's jump into the next thing, which we need to understand before we actually dive into the crypto APIs. So the next thing is the crypto key. Now, crypto key is one of the most important things we need to understand before we start using the web crypto APIs. Now, what is a crypto key? Well, crypto key is basically an opaque representation of a cryptographical key, which you are using for encryption and decryption. Now, when I say it's an opaque representation, what I mean is you can't view the bytes of the crypto key. Even if you are the one who has generated it, still you can't view the bytes of the crypto key. So it's for the security purpose. Basically, you can't use it outside the app. All you have access to is these 4 parameters, which you can see in front of your screen. So let's have a look. What are these parameters? So the first is type. Whether it's a secret key or it's a public key, like depending on whatever algorithm you are using, this type will be set. Now algorithm. Now what is name of the algorithm and what are the different parameters? Because each algorithm may have different parameters depending on how the algorithm works internally. So it's an object where you pass in the name of the algorithm and the additional parameters which that algorithm will require. Then usage. For what purpose are you going to use this key? Whether it's for encryption, decryption, signing, what is the purpose? So if you, let's say that, hey, I'm going to use this key for encryption, and you try to decrypt using this key, it will not work. So you need to be sure for what purpose are you going to use it. And extractable. So this is one of the most interesting and my favorite parameter when it comes to the crypto key. As I mentioned that you can't really view the bytes of the crypto key, but you can say that, hey, at the time of generation, you can say that, hey, I need to extract the bytes of this crypto key later because I need to view the bytes. So with the help of this parameter, you can actually extract the crypto key. So for example, when I'm sharing the mockup with you, I need to share the key with you, right? Otherwise, how will you decrypt it? So for that, when I generate the crypto key at my end, I'll set this parameter as true, of course, right? So you need to be sure, because if you set this parameter as false and then you try to extract the bytes of the key using the export API, which we will be covering in a bit, it will not work. So you need to be sure the requirements, what you have at the time of generation itself. So that was a bit about the crypto key. And now we know about the crypto key. Now let's understand what is the algorithm that we are going to use for encryption and decryption. So we are going to use AES GCM 128-bit encryption algorithm. When it comes to AES or Advanced Encryption Standard Algorithm, there are a lot of modes which are supported, like counter mode, block cipher mode. But GCM is one of the modes which is the most recommended mode because it comes with authentication. So making sure that your data is not really tampered or corrupted when you are encrypting or decrypting. So that's why GCM is what you should use if you're going for this algorithm. And 128 is basically the length of the crypto key. So yeah, that's the length of the crypto key, and it's a symmetric key algorithm, meaning me and you are going to use the same key for encryption and decryption. So that was a bit about AES and AES GCM. So I think we covered a lot of things, a lot of new things. So and visualization is something which helps in better understanding, right? So I have a quick demo for you all to make the understanding better, where we can play around these parameters which we just discussed. So let's actually go to the demo. But before that, let me just give you a quick overview about the additional parameters, or what are the parameters which this algorithm will need. So let's just cover that, because then we will have a better understanding of how we are going to use this algorithm. So it needs a crypto key. Every algorithm will need a crypto key. So that is something we already understood. But in addition to that, it also needs an initialization vector. So what is an initialization vector? It's basically, I'll refer it to as IV for short form. So don't worry about this. It's basically a random set of integers which makes your encryption more stronger and harder to decrypt. So it does some magic, let's consider, which actually, makes your algorithm more secure. So you will be able to better understand when I actually show you the demo. So let's actually go to the demo now. It's out there. Like you can even you can play around with it. And 1 second, let me just move this somewhere. Okay, I'm not here. Okay, 1 second. Yeah, now I'm able to move it out. So yeah, you can actually go and visit this, and it's on GitHub. The code is also open source. So if you come across any issues, feel free to open any issue event. And if you have any, enhancements you want to do, feel free to make a PR as well. So it's basically what we talked about. The crypto keys here, the data in bytes, the encrypted content or the buffer, and the IV. So let's try to play around with it. I'll generate a crypto key, and maybe since we are at Pesto tech, so maybe I'll just write here Pesto tech. And as you can see, as I type in, you can see the bytes format as well for this text. And let's try to actually encrypt it now. So yeah, so you can see as I'm encrypting the data, you see the key remains the same. The data in bytes remains the same, but the IV is changing, and so is the output, the encrypted buffer as well, right? And this is what I was talking about when I mentioned that IV is basically making your algorithm more stronger and harder to decrypt. So even if you are encrypting the same data multiple times with the same key, but using the different IV, the output will be different, right? So it makes it difficult for someone to actually hack it. So that's one of the reasons why this algorithm is also makes it more, the IV makes it more stronger. So now let me, this is the encrypted version. Now let's actually go to the decrypt. So maybe let me try to view the bytes of this crypto key. Okay, I'm not able to extract it. Can anyone point me out what just went wrong? Why I'm not able to extract it? Did I make some mistake? Can you figure it? Can you see something here? What went wrong actually? Do you think, any guess? Like you can type it in the chat. What do you think? Oh wow, okay, Satyam, you are right. The extractable parameter is actually false. So and that's the reason I'm not able to extract it. So as I mentioned, if you mention it as set it as false, you will not be able to extract it, right? So let me mark it as extractable and try to generate it again. And now you can see it's set as true. So let me try to view it. Okay, I'm actually able to view the crypto key. So view the bytes of the crypto key. So this is the key which I'll be actually sharing with you when I share the mockup. So let me actually encrypt it again, because I changed the key as well. And yeah, now let's go to the decryption. Maybe I'll just copy this key here, and this one, and I need this buffer as well. So this is the one I'm going to decrypt, and it will ask me for the IV as well. So maybe, yeah. Okay, decryption is failing. Can you help me out here? Like, why do you think it failed? What, I did copy all the parameters, right? So why do you think it failed? What went wrong here actually? Did I do some mistake, or is there something wrong going on? What do you think went wrong here? Okay, I got an answer that yeah, IV is wrong. I mean, I did a bit of cheating. If you notice, I actually changed the IV. So the IV was here, I think 177, and I actually changed it to 178. So yeah, now let's try to decrypt it. Hopefully it works. And it worked. Okay, so we are successfully have decrypted the data. And I hope this demo helps you to visualize things in a better way. Do check it out and just play around with it. And yeah, so let's go back to the slides. So now, now we are actually going we will be diving deeper into the implementation part, because now we have covered basics of Web APIs. So before we actually go into the implementation, we first need to understand how the data looks like. Now, when you're using Excalidraw, as I showed you, like your mockup or whatever mockup I'm going to share with you, it is basically a buildup of multiple elements, right? So how does each element look like? So each element is basically a JSON. It has a type, it has XY coordinates, the dimensions, and a lot of extra attributes, which keeps on getting added as you add more and more features. So now that this is an individual element and we have multiple elements, so it's basically array of JSON or array of objects. That's what I'm going to encrypt at my end, right? So let's look at the encrypt API. The API which we are going to use is crypto.settle.encrypt, and it needs the name of the algorithm, the IV, the crypto key, and the data in bytes. And we are aware of all these 4 parameters, right? So there is nothing new in this. But now, how do you actually generate these parameters is what we are going to cover. So let's cover it one by one. Let's first check the IV. IV is basically those random set of numbers which was making your encryption more stronger and harder to decrypt. So how do we generate the IV? It's very simple. So since we are using the UE data array, you just create in a UE data array of 12 bytes, and then we just need to fill this array with randomized values. So for that, we use something called crypto.getRandomValues. Now, when you are using cryptography APIs, it's recommended that you use crypto.getRandomValues if you are dealing with some randomness. The reason being, this API helps you to, create cryptographically more secure random values as compared to math.random. So that's the reason it's recommended you should use this API when you are using cryptographical APIs. So yeah, so IV is done. We know how to, generate the IV. So now, what is the next thing? Crypto key. We know what a crypto key is, and what a crypto key is. So I think someone is asking, please explain what is crypto or subtle. It's basically subtle is basically one of the APIs which we are going to use, where you will find a lot of inbuilt, which has a lot of APIs like encryption, decryption, signing, and lot of more stuff. And when it comes to using the web crypto APIs for encryption and decryption in the browser, so that is basically the subtle. That is basically what subtle consists of. So yeah, so let's actually go into how you actually generate the crypto key. So yeah, basically this is the API which you use to generate the crypto key, crypto.subtle.generate key. And the name, you need the name of the algorithm. The length is 128, as I discussed earlier. Of course, I need to share this mockup with you. So I need to extract the bytes. So that's where the key, I'm setting the extractable parameter as true here. And I'm going to use this key for encryption and decryption. So I'm setting that as well. So I think the parameter look fine. And as soon as the promise is resolved, you will get the crypto key. And this is how the crypto key looks like, what I showed you earlier. These are the 4 parameters that you have access to. So yeah, I think crypto key is also done. IV is also done. What is left then? The data in bytes is actually left. So the array of objects which we have in Excalidraw, we need to represent it in bytes to make it compatible with this API. So let's actually go and do that. How do you actually convert that data in bytes into the array of elements, array of JSON into bytes? So that's actually pretty simple. You actually first stringify the data, and we covered a couple of minutes back. How do you actually convert the string into bytes? Anyone, if you checked, if you were there in the previous like the beginning of the talk, anyone point me out how can you actually convert the string to bytes? What is the API you use it for? You use to convert the string into bytes? Awesome, Sagar. Text encoder dot encode. Yeah, that's the API which we are going to use. And now you have the data in bytes. So yeah, I mean, all the three parameters are done. So let's go ahead and encrypt the data. And once the promise is resolved, you will have that encrypted buffer, which I was showing you in the demo. So that's now you have that. So the encryption part is done, right? And I can actually just go ahead and upload the data to the server, which you can later fetch the data at your end. And I'll be sharing the crypto key with you. I mean, the extracted format of the crypto key with you as well, with the help of export API, which I'll cover in a bit. Is there anything else you need at your end to decrypt the data apart from the encrypted blob and the key? Do you need anything else apart from that? Just think about the demo. Yeah, Samarpan, you are right. We need the IV, right? So I need to actually make sure that I share the IV and also keep in mind the exact same IV. It should be the exact same IV, because if you just change a little bit IV here and there, it's not going to work. So let's understand this fact that IV is not really something very confidential. And it's going to change every time you encrypt the data, right? We are going to change the IV. So every time you encrypt the data with the same key or a different key, you still change the IV, so you get a different output. For security purpose, that is good, right? So we can actually store this IV to the server. So there are different approaches you can go about. One of the approaches is that let's store this IV to the server as well. So what we do is we append the first 12 bytes in the payload will always be the ID, and the rest is the encrypted blob. That is the deal which we have. That okay, when you fetch the data at your end, just make sure that you extract the first 12 bytes if you want to know the IV, and rest is the encrypted buffer. So let's do that. Let's just upload the payload. And once that's done, the backend part is sorted. I mean, I'm done with the backend part. The data and the IV are both uploaded to the server. What is left is I need to still share the key with you, right? And we still haven't discussed that how do we extract the bytes of that crypto key? That is something we need to figure out. So for that, we actually have an API for that as well. You have the API for everything, don't worry. So we have this API called crypto.subtle.export key. And there are actually a lot of different formats if you go through the MDN docs. And JWK is basically one of those format when it comes to exporting the key. You can choose the format which you want to. Now we chose JWK, which is basically a JSON. So when this promise is resolved, you get this JSON, and it has all these parameters, out of which key is actually the encryption key. And that is what I care about. So that's where I'm just extracting the K parameter if you see here, because that's what I just care about. And this is what I'm going to share with you. So I have this key now. I'll just go ahead and create the URL, right? I'll just append it to the hash as we discussed, so that it is not shared with the server, and I can directly share it with you so that you have access to the key. So this is the URL I get after I actually, get the key. So the first parameter is actually the ID, basically the ID which will help you identify the drawing in the server so that you can fetch the right drawing. So don't worry about that. But the second parameter is what we are actually more focused on, the encryption key. So I'm done with my job. I have encrypted the data at my end. Now, how do things work at your end when you actually open this URL in the browser? what happens at your end so that you decrypt the data successfully in the browser. So my current just power cut just happened. So you might get a blink. So yeah, but I think it's just coming back. So yeah. So yeah, 1 second. Just give me a second. I'll just arrange my screen again. So yeah, when you open this URL in the browser, what is the first thing you do? You have the ID of the mockup. So just go ahead and fetch the data from the server. That is the first thing you want to do, right? So just go ahead and fetch the data from the server. And now you have the payload, which I had uploaded to the server. You have that payload with you. You just fetched it. So let's look at the Decrypt API. So Decrypt API looks exactly same as the Encrypt API. It needs exactly the same parameters which the Encrypt API also needs. It needs the IV, it needs the crypto key, and it needs the encrypted blob. So you have the payload with you, which I just uploaded. Do you know what are the parameters? Do you think if you have any of these parameters when you actually get the payload from the server? Do you have any of these parameters? Just type in the chat. Now, when you actually download the payload from the server, what the parameters you will get from these actually. Okay, awesome. Yeah, you are right. IV and blob. Yeah. So we get these two parameters, right? We already discussed that. That's what I'm doing here. So let's actually then, we'll just extract the IV and the encrypted buffer. We already have that. The first 12 bytes will go to the IV, the rest is the encrypted buffer. So we have it. Now what is left? The crypto key. Now tell me this. Do you have the crypto key with you? Just whatever we discussed so far. Okay, Satyam says we. Yes. Anyone else? Do you have the crypto key with you? All right. Are you missing some fact? Crypto key is something where you can't view the bytes. Do you have something like that with you? What I shared with you is actually the extracted bytes of the crypto key, not the crypto key, right? I cannot share the crypto key with you because it's just that object which you can't really, which is useless. You can't really share it with anyone. So, but this API actually needs the crypto key. So what I shared with you was the extracted bytes of the crypto key, not the crypto key. Okay, it was basically the exported format. I used the export API to extract the bytes of the crypto key and I gave it to you. But now this API needs the crypto key. So we need to backtrack. We need to go back and generate the crypto key from the extracted bytes, which I shared with you. So let's just, memorize whatever let's just go back and imagine what all we did. I had the crypto key with me. I used the export API and converted it to a JWK format, which had a lot of attributes. And I just took the K attribute and gave it to you, right? You have just the K attribute. Now, what you have to do is you have to take the K attribute, add the additional attributes so it can go back to the JWK format. And then we can actually go back to the crypto key from there with the help of some API. So let's actually go into how it happens. So we just add the missing attributes to convert it to a JWK format, because what I shared with you was just the K attribute and all other attributes are actually constant. So you can just hard code it. So these are the attributes and you can just hard code it. So now you have generated JWK format, which needs all these attributes. So now I was using the export API, right, to extract the bytes from the crypto key. Similarly, we have an import API, which will actually take this exported format and give you back the crypto key from that there. So that's what we are going to do next. We just take this JWK format, run it through the subtle.import key API and get back the crypto key from there. And this time we actually don't have to make it extractable, because once the content is decrypted, we don't need to view the bytes, so it's false in this case, and it's only used for decryption. So now you have the crypto key, and this is what is compatible with the API. So now you can actually go ahead and decrypt the data, and once the promise is resolved, you will get the decrypted buffer. I was stringifying the data, so you will be just doing the opposite. You will be parsing it. I was encoding it, so you will be decoding it. So it's basically reverse of all the process which I was doing at my end. So yeah, now once this is done, we can successfully, we have done the end-to-end encryption, and that is, we actually did a very deep dive, and I really love that you all interacted with me during the talk. Really, thank you for that. So before I wrap it up, I would like to give kudos to all the contributors who have helped us make Excalidraw what it is today. So kudos to all of them. And I had like when I was learning about these, crypto APIs, I actually started working on a side project, cryptmoji.in. So, and this is the first time I'm actually talking publicly about this project. So you can check it out. It's basically a fun project which I was doing when I was actually learning about this crypto APIs. So what you do here is basically encrypting the message in form of, emojis, math or Latin symbols. So let's say I want to just encrypt here, hey, I'm Akansha, and maybe I'll just type in a password. What's the date today? March 18, 2023. And I can encrypt it. So instead of those bytes, those zeros and ones, it's actually emojis, but it has a hidden message inside it. And you can even change it to, maybe some Latin symbols or maybe math, whatever works for you. And with the help of Ivy, of course, it's again changing here, the same thing. And in this case, it's like not the key, rather you are deriving the key from a password, which the user knows. So I can share the password with you. So you only know what the message is hidden inside this. So let me just try to, decrypt this here. And I'll paste it here. And password was like March, what is it, 18, 2023. Sorry, I think I typed something wrong. March 18, 2023. So yeah, it works. If you try, changing the password, it should not work. So yeah, you can play around with it. It's on GitHub, it's open source. If you have any enhancement, open an issue, we can discuss about it. But yeah, this was just a side project, which I just was doing some experiment to, understand more about the crypto APIs. So I would not be able to cover what all APIs I used here because that would be like out of scope for this talk, but you can check out the code. And yeah, I think there are few resources which, if you want to learn more about crypto APIs and how, in the internals of it, you can go through these resources. And yeah, I think thank you all of you for joining today, spending the weekend, like Saturday Eve. And thanks again, the entire Pesto Tech team for having me. It was really great. And I think the most amount of interaction I have actually seen so far, I really liked it. So yeah, thank you. Open up for any questions or tech, non-tech, whatever you want to talk about. But before that, I have a request. If you can, some of you can switch on the videos. I just want to take a picture with all of you. So can we do that? Like maybe if it's possible, if you can, some of you can share the just switch on the videos. It will be better. And I just want to take a picture. Okay, I can see some cameras getting open. So great. So yeah.
As in the meantime, we're also open for questions. So if you have anything that you want to ask Akansha, you can put it on the chat screen. Yeah. Akansha, whenever you're ready, there is one question for you.
Yeah, one second. I'll just check the chat. I'm okay.
Do you want me to read it out for you?
Yeah, I can see. So what is the risk of using web crypto API? Actually, if you are really building some, Android encryption or using this web crypto APIs, it's actually recommended that you even take an expert opinion from, cryptographic crypto expert, so that you are sure that you are using it the right way. Because as I told you that, these API have some strict requirements which you need to fulfill to get the maximum security out of it. So you need to understand how this, like you need to have a very good understanding of these algorithms, how does it work and what all it needs. So yeah, but now there is not like a hit API rate limit. As far as I know, there's nothing like that. We have been using it in Excalidraw, and there is nothing mentioned as such in the docs as well. So I don't think there is anything like that. Any live and popular examples where web crypto API is already using? I mean, I can't really think of any example as such, you can check out the side project I had made. The Excalidraw also using it, and I also know, I think some was one Google Forms alternative. I just can't remember that name, but they are also using, I think, the same thing. They are also using Script APIs, but I just can't remember the name. But yeah, I think few of them are actually using it. Any other questions or anything if you want to ask? Yeah, I have added some resources. There is also a video. I'll share the slides as well, so you can actually check it out. So you can check those resources in the slides, and you will get a better understanding of the crypto APIs. The API makes a call to the remote server that gives you back the key. I am not sure which API are you talking about here? Like, are you talking about the crypto.settle.generate key? It's actually working under the browser only, or not really making any API call. No, because these are only client-only APIs. Yeah, in Excalidraw, we use WebSockets, and the collaboration is also end-to-end encrypted. Use case of using web crypto APIs, as I told you that, if you are having a project where you think that the server doesn't really need to see the data, like for Excalidraw, the server doesn't, we don't really need to see the data. So that's where we actually ended up encrypting it on the client. So if that is the use case where server doesn't need access to the data, then you should use then web crypto is actually a very good option, because then you are actually encrypting the data right on the client and storing the data on the server. Will you please share strong advantages? I think the strong advantage is end-to-end encryption, because you are actually encrypting the data on the client. So that is giving you a strong encryption, because the server will not have access to the data at all. So, but yeah, this use case depends on whether it goes with your product, with whatever project you are working on. If like there are products which need access to the data, so in that case it's hard to do this, because your server will still need access to the data. But if you are using this crypto APIs, and if your server doesn't really care about whatever data it is, it just needs to, you are just using it as a storage, then definitely go for the web crypto APIs. Yes, we store the encrypted data on the server, right, in Excalidraw. KPI websites. I think, as I mentioned, I have a few. I think there are. I have to, maybe I'll have to check and get back to you on this. There are few products I know which use these crypto APIs. If you are talking about real life usage, as like alternative Google Forms is there, or that I don't remember the name. But apart from that, I think there are a few. I'll need to check it and get back on it. But yeah, you can connect with me, and maybe I can then get back to you on this. I think, yeah, just check I think the same questions. It's like as soon as share the slides, you will have the details. I've shared the resources. Whatever I talked about, it's already on the MDN DOS. You can check that out. And if you want to get a better understanding, I've also shared those in this. If you see here, these resources, you will get everything there, whatever I have discussed so far. Back in TypeScript framework, Excalidraw is actually completely front end. So we are just having a Node.js server for storing the data and everything. Otherwise, the framework or whatever you use the stack, it's actually React plus TypeScript. What will be the performance hit on the client machine? It depends. So as I told that, it depends on I won't say you will be able to hit the performance, performance in any case, because when you are using this, let's say 128-bit encryption algorithm, and there is a 256 encryption algorithm as well. So if you have to make a choice, I've also shared an article. Yeah, this Ubiq security, you can actually take a look at that. So the more the key is stronger, your algorithm might get a little slower. So is it a choice you want to make? It is a choice you have to make. Because let's say if you're considering 128 versus 256, when it comes to AES, 128 is very, very fast. compared to 256. Of course, 256, the length is strong, so the key, the entropy gets like more, it becomes more harder to, hack it or decrypt it. So that is there, but the internal algorithm stays the same. So that is the choice you have to make, whether really you need to go for the 256, or is 127 a good choice for you. So as the key gets more, stronger, then it becomes slower. Like the example I showed in that side project, I'm actually deriving the key from that password. So as I increase the number of, chances, number of iterations to generate that key, if I keep on increasing that iteration, the algorithm will become slower. So that is something you need to decide. What is the limit, and what is the best limit for you, and what you need to go with. But yeah, it should not be like you should not hit the performance issue if you go the right way. How do you keep your updated? I think reading blogs is one good way. Subscribing to newsletters. There are a lot of newsletters which I've already subscribed to for front end, where I keep getting updates about what is coming, and what is the new thing. What are the new projects or open source projects which are coming in. And I think maybe also keep yourself updated, like what is the hot topic going on right now. So even social media also helps in getting that. But yeah, mostly I think it blogs and newsletters is what I would suggest if you want to stay updated. When there are multiple collaborators working simultaneously on Excalidraw session, would everyone have different keys, or everybody in that session would be using the same key? So if you are talking about collaboration, the URL is same, so everyone is using the same key. And that's how they are actually collaborating, because if you have different keys, then it's a symmetric key algorithm. You need to have the same key, so it will not work, right? So now AES is actually a symmetric key algorithm where each of you will be using the same key for encryption and decryption. So the URL, the key stays the same. Definitely just ping me on Twitter. I'll ping you the newsletters.
Right. I believe we're almost at the end of it. So, thank you, Akansha, for doing this session with us today. And thank you for being so patient with all the questions and answering them all. And I hope you guys, you've all learned something new today. And it would be great if you could fill the feedback form, which is being circulated as well. Yes, Akansha was very patient and she answered all of it. So yeah. Definitely. Can we show some appreciation on chat for Akansha then for conducting a great session here? Yeah.
I think,
All
yeah,
right.
I mean, thank you again. It was a great experience for me, Shreya. So I think thanks to all of you, and especially the audience. That really matters when, for the speakers, because if the audience starts interacting, it just adds on energy to the speaker as well. So I think that was really the best part of the talk, that people were answering the questions which I was asking, even texting there. So I mean, I was like really happy with the session. And I hope it was helpful for you, for everyone.
Definitely, it was a successful session because the participants were also, answering on chat like you mentioned, and overall it went great. You were patient. You explained everything nicely. So again, officially now I just close the session. I hope you guys have like a great weekend ahead. And thank you for joining in again. And thanks, Akansha, again, once again for doing this.
Have a great weekend. Thank you.